Hey YouTubers, K here from the Brain Booster Academy. Welcome to the second lecture of the series, sequences and series. Now before that, once again I have to repeat that GRE and GMAT Quants don't attempt to pressurize you with time, so focus on concepts and not formulae and you'll be good to go. And that is what I'll be giving you here, the concepts. Alright, so sequence can basically be any list of numbers in the literal sense. When dealing it in mathematics, you try to search for some logic, and that is where series comes in. So a series of squares, a series of cubes, a series of Fibonacci terms, which is basically the sum of the last two terms beginning with 0 and 1. Some complicated it a bit more by asking stuff like a series in which the common term is 2n minus 1 or n squared plus 1. Here n stands for the nth term of the series. So you substitute n with, let's say, 1, 2 or 3 and you get the first, second or third term respectively. Now there are a few complicated ones that you have to derive the common term, but that is way beyond our syllabus. GRE and GMAT tests you only on the basis of the commonly known or adaptive sequences and series as mentioned above. Now a summation of the series that I would want to focus here, basically four things. Firstly, sum of the same number n times is obviously that number into n. So a sum of 5 10 times is 50. A sum of consecutive numbers from 1 up to n is n into n plus 1 by 2. Just keep this in mind. So for the first 5 numbers it will be 15, for 20 it will be 210. If you want to find the sum of the numbers from 100 to 200, you basically find the sum of the first 200 numbers subtracted from the sum of the first 100 numbers and you're good to go. Pretty logical, right? Alright, similarly, the sum of the square of the first n natural numbers till n square is n into n plus 1 into 2n plus 1 by 6. Finally, the sum of the first n cubes, that is till n cube, is n into n plus 1 by 2 whole square. Now, why am I sharing this? Well, this is to introduce to the general concept of summation. Now, if you have a general term of any series, let's say n square plus 2n plus 1, and you're asked to sum it up for the first 10 terms, you can simply use the above formulae and substitute it with the corresponding structure. So for this, for n square, it will be n into n plus 1 into 2n plus 1 by 6, plus for 2n it will be 2 into n into n plus 1 by 2, plus for 1 it will be 1 into n. So now just substitute the value of n and you don't need to do anything else. If it's, let's say, from n is equal to 3 to n is equal to 10, then once again you have to find the sum of the first 10 numbers, and then you find the sum of the first 3 numbers, you find the difference and you have your answer. This is a simple trick that might come in handy at times. Alright, now let's move on to something very important for this topic, that is arithmetic progression or AP, geometric progression or GP, and harmonic progression or HP. Now these are ridiculously simple yet very important concepts, so just focus on this. So AP is basically when the difference between consecutive terms is the same, like 5, 10, 15, 20 with a common difference of 5. GP is basically when the ratio of the consecutive terms is the same. So 5, 50, 500, 5000 with a common ratio of 10. HP is not that common, but it's good to know. It is when the reciprocal of the given terms are in AP. So for our AP example, just put in the reciprocals here: 1 by 5, 1 by 10, 1 by 15, 1 by 20, and so on. Now, I went through this quickly because I wanted to focus more on the shortcuts and the tricks involving the concepts of AP and GP, and you'll love this part of the video. Alright, so for AP, let's say we have an AP with the first term, or A, as 4 and a common difference, or D, as 6. So 4, 10, 16, 20, and so on. Now for any nth term, it is A plus n minus 1 into D. So if you want to know the 100th term, it would be 4 plus 999 into 6, which is 598. So if you want to know the 100th term, it is applying this formula, we get 598. It actually makes sense, since after the first term the difference keeps on adding up, and it is after the first term, so n minus 1, right? Also, the sum of the n terms of AP is n by 2 into 2a plus n minus 1 into d. I'll explain this in a minute. Okay, So using this formula for, let's say, 100 terms, we find the sum as 602 into 100 by 2, that is 30,100. This looks pretty easy. I hope you got that. And moving to GP, let's say we take a simple example of 1, 10, 100 and 1000. Common ratio, once again, just divide 10 by 1, that's 10, or 100 by 10, that's 10. And you got the common ratio, or R, as 10. Now in its term, in this case, is a into r to the power of n minus 1, which is again pretty obvious because after the first term we keep on multiplying the ratio, but only after the first term, hence it's n minus 1. Also the summation of this is a bit crooked, so it's basically a into r to the power of n minus 1 by r minus 1. I'm intentionally not going to focus on HP, as firstly you can solve it by simplifying the reciprocals and using the AB concept, and also it doesn't have any formulae as such. Okay, now comes the interesting part, the means. Now arithmetic mean is simply the middle or the average. So for the similar example, 4, 10, 16, 22, 5, 92, 598, we have 100 terms. Now if you wanted to find the average, normally we would sum all of them up and divide it by 100 and so on, right? Well, you don't have to do that right here. So for arithmetic progressions, the mean for symmetric terms is the same throughout the series. Now what do I mean by that? I mean the first term and the last term, the second term and the second last term. The means of all these is the same. In this case it's 301. Now this is pretty important. This symmetry is crucial when you're solving sums. So remember that. Now if we want to find the sum of all the terms, how did we do that earlier? We simply used to multiply the average with the number of terms, right? Similarly over here, you find the average by, let's say, taking the sum of the first and the last term and then dividing it by 2 and then multiplying it by n, or the number of terms. Now this would give us the same formula as we had for the sum of the AP. So I hope now you can establish a link over here. Once again, for geometric progressions, or for the geometric mean rather, it's the similar symmetry concept, but here it's the product form of it. So for the GM, it is basically the square root of the first and the last term, or the second term and the second last term. So for the geometric mean, it is basically the square root of the product of the first and the last term, or the square root of the product of the second and the second last term, and so on. Try figuring out the summation formula for GP from this. Let's see if we can. Alright, so there are loads of sums to be practiced here. Please do this extensively. These are the basic concepts. I'll just give you a few tips and tricks that you might find useful. So at times during calculation, when you want to find unknowns, and let's say you're given the sum of the three terms of an AP, you can assume the terms as a minus d, a and a plus d, because when you sum them up, then the d's or the differences get cancelled and you just have one unknown, that is a. Also, if it's 4 terms, then it's a minus 3d, a minus d, a plus d, and a plus 3d. But remember here, the common difference is 2d. So for GP, you can use a similar logic. Here it would be a by r, a and ar. Why? Because in GP generally you have questions in the form of products. So if you multiply these three terms, the ratio cancels out. If it's 4 terms, just switch it a bit. It's a by r cube, it's a by r, ar and ar cube. So if you find the product of all these, once again the r cancels out. But once again note that the common ratio is not r but r square. Thirdly, it is important to note that for a given set of numbers, the arithmetic mean is always greater than or equal to the geometric mean, which is also greater than equal to the harmonic mean. Remember this because questions can come in some manner for this, although it's not that common. The equality only happens when the numbers are the same, when the numbers are equal. And once again, I cannot stress this enough, practice this topic a lot. These are all the theoretical concepts that you need for sequences and series and progression. This is a very scoring area. A lot of people ignore this, but finding unknowns is very easy once you get the concepts. You don't need any more formula. Follow this, note this down, go through these points and start practicing. But hey, do hit the like button because I know you did. Also the subscribe button and the bell icon, because if you're a serious candidate and you want a perfect score, you do not want to miss any video. And finally, let me know through the comments any pointers, any doubts, anything that I should work on, and I'll see you in the next video. Until then, bye.